Welcome to the MOTIF demonstration. We will show how to perform mutation testing with MOTIF applied to space software library. The target software is ASN1lib, which is a library of serialization and deserialization of data structures generated by ASN1 SCC. This is the source code of the library under test. We are targeting one source code file called test.c. To perform mutation testing, we first generated mutants with a mutation analysis tool called MAS. For example, this is showing a mutant for a function in the file test.c. MAS changes a comparison operator in the for loop. We have several mutants with various operators. In this demo, we will apply MOTIF to kill a subset of the live mutants. To provide the required input for MOTIF, I created tar files with the source code of the software and the mutants and put them in the MOTIF workspace. I specified the live mutants to be tested in the file live mutants. To execute MOTIF, we need to configure the options in the file config.py. The first section is about locations for the input files and outputs. Our default options do not need to be modified. The next section is about compilation options. They are separated into several variables since MOTIF uses them in a various contexts. The last section is for the manual configuration of fuzzing drivers. These variables change how fuzzing drivers are generated when it is necessary. MOTIF execution can be done with the entry point runList.py by passing a timeout for the fuzzer of 100 seconds plus the list of live mutants. Then MOTIF will generate fuzzing drivers and seed inputs for each mutated function. After that, it will build executable fuzzing drivers for each mutant and execute fuzzers. If a mutant is killed, MOTIF will generate test cases using the input killing the mutant. To visualize the statistics of the mutation testing run, we provide an auxiliary tool run corrector with similar parameters to entry point. The result shows that we killed all the mutants. Let's now take a look at the generated test cases. This test case calls the function on the test by providing the input values that kill the mutant and were generated using the fuzzer. These input values are stored in the test case as hex. The test case also includes some print instructions that show the inputs and outputs of the function. They are necessary because engineers should verify if the outputs of the function under test are correct. If they are, the test case can be reused for regression testing as is because MOTIF generates test assertions. The expected values are also provided as hex above. They are obtained from the execution of the function under test with the input, assuming the function is written correctly. If I execute the test case, the generated print instructions visualize some data in hex format. To facilitate manual verification, we also provide GDB scripts that enable a better visualization of the output, especially for the data structures. For example, in this case, we can see all the values belonging to the fields of the data structure. Thank you for watching our demo video. If you want more information and code, you can visit the website.